My name is Pranav Dar. I am a data scientist and a senior editor at Analytics Vidya. I'm a bit of a data visualization expert. So you might have seen me on LinkedIn talking about all sorts of data visualization tips, tricks, and techniques. I personally love working on data visualization projects ranging from analyzing the cash flow of companies, sales and profit figures to analyzing the cricket and football numbers that are happening in the sports world. Whatever the domain is, I love working and diving into the visualization aspects. I bring almost a decade of working experience with Microsoft Excel. I've been using it ever since I got into the industry. Previously, I was working with an MNC for 5 years in their learning and development department, where we used to use Excel to create various reports, dashboards, and so on for our clients. That's why I have a rich background in reporting and BI as well. And I'm also an instructor for multiple courses on analytics Vidya. So I'm part of the AIML Black Belt program. I'm one of the core instructors there. I'm part of the applied machine learning course, the Tableau course, structured thinking, and so on. Teaching is one of my biggest passions, and I love giving back to the community. That's one of the biggest reasons why I'm part of the entire instructor pool at Analytics Vidya. Kunal Jain is the founder and CEO of Analytics Vidya. He has a ton of experience in data science and analytics, 12 plus years. He's worked across various geographies and domains, and he's led data science and analytics teams and projects in big companies like Capital One and Aviva Insurance. He's a data science and analytics evangelist. You'll see him talking about the various components, the various aspects of data science and BI and analytics on social media. He takes parts in webinars. He's invited to conferences, and he's one of the best people who could teach you about Excel and about the data science and analytics world. He's also worked with several clients to build their data science capabilities from scratch. And Sunil Ray is the Chief Content Officer at Analytics Vidya. He brings over a decade of awesome experience working in the data field. He is an Excel master. He has unparalleled understanding of Excel. The way he works in Excel, the quickness and efficiency with which he analyzes data in Excel is unrivaled. He's worked for several insurance companies in his career, so he has a very good hold on number crunching, data wrangling, and his ability to break down complex topics into easy to understand concepts is a very helpful thing. As you'll see throughout this course, and his ability to break down complex topics into easy to understand concepts is something you love working with in the course. We will learn about the different components of an Excel formula, things like operators, operands, what is a function. We learn about the order of operators, basically how is an Excel formula evaluated. And yes, we will talk about cell reference as well, which includes, you guessed it, VLOOKUP. That is all part of this module. Let's start from the basics. What is an Excel formula? An Excel formula basically is a simple mathematical equation that combines operators, operands, and functions, and it returns an output. This formula that you're seeing in this slide is what a typical Excel formula looks like. So the question arrives, what is a function, what is an operator, and what are operands here? Here, sum is the function, the plus and asterisk, which is a multiplication, is the operator, and the quantity that's being operated on is the operand. So 7, 24, the range D5 to D7, these are operands. It's really that simple. Now I want to talk to you about some key things about formulas, something you should always keep in mind when you're using Excel formulas. Remember, a formula should always in Excel start with an equal sign. If you don't put an equal sign, the formula won't evaluate. It isn't a formula essentially. Next, formulas output change repeat. Next, remember that formulas are dynamic in nature. So whenever you change the value of an input cell, that will change the formula's value as well. This is helpful as well as a cautious point to note in case you casually just copy paste a value somewhere else and it might change the formula. So keep that in mind. Formulas, as I mentioned, can be copied from one cell to another, and you can perform all sorts of basic mathematical operations in Excel. And not just mathematical operations, there are a whole host of operations you can perform with Excel formulas like statistical formulas, financial formulas, string, date and time, and many others. Now that we have a grasp of what Excel formulas are, let's see how a very basic one works in Excel. So let me open up an Excel workbook. There we are. So here we have some basic information about employees' salaries. So we have these 10 employee IDs, and we have the basic salary, the allowance, and the TA, which is the travel allowance for each employee. Now we want to calculate the payout for them. Here, the formula for payout is actually very straightforward. So payout is equal to the basic salary plus allowance 1 plus the travel allowance. So it's a basic addition here. How do we do it? We already saw how to calculate the sum in the slides, right? Let's put that in action. Remember, is equal to sum. Now we want the sum of these three columns, right? Basic, allowance, and TA. So take your mouse to C4 and drag it to E4. That's it. Just press enter. And there you are. That's the total payout for employee ID A001. This is where your previous knowledge about autofill will come into play now. Take your mouse, wait for the plus sign to appear, and just double click it. And there you go. The total payout for all the employees has come up here. And with just a click of a button, it's very easy. Now I want to calculate the total of basic, allowance 1 and TA as well, because it helps the organization, helps the HR and the finance team to understand the breakdown of each of these components of the salary. So what can we do here? Well, multiple ways. You can either calculate it one by one. You can do C4 plus C5 plus C6 and so on, but that's too laborious, it's too manual. Again, we head over to the sum. So sum, move your mouse to C4, drag it all the way to C13, that's your range, and just press enter. And there you are. You have the total basic salary. And to calculate the total allowance T and the total payout, drag your mouse all the way over to F14, and there you are. So in a matter of seconds, we've not only calculated the total payout, we've also calculated the total basic, total allowance, total TA, and the total payout for each individual employee. Now imagine calculating all of this at a grand scale in an organization that has hundreds, if not thousands, of employees. You can't do it manually, it'll take days, if not weeks. This is where Excel formulas really help us out. So let me head over back to the presentation. I want to take a moment to look at the type of operators and the evaluation order of operators. So Excel essentially has two types of operators. One are mathematical operators, which you're seeing in this slide. So mathematical operators like addition, subtraction, multiplication, division, percent, exponent, and brackets. And the other type of operators are comparison operators. As the name suggests, equals, greater than, less than, greater than and equal to, less than or equal to, and not equal to. But the question then arrives, how do you evaluate an expression? How do you evaluate an equation? Which operator should come first, right? Because typically you'll be working with complex equations that have all sorts of mathematical operations. You might have addition, subtraction, division, brackets, and multiplication all inside one equation. So how do you evaluate it? Well, this is how it works. Excel first evaluates items in parentheses or brackets and then works inside out. Then the formula uses the order precedence rules of mathematics. Remember BODMAS? That's how it works here. And when two items have the same precedence, Excel works left to right. Let me show you how it works in Excel. So let me just take a simple equation. Let's say 2 plus 3 inside brackets, and let's multiply this by 3. What do you think will be the output here? Remember, Excel will calculate the brackets first and then the multiplication sign. So 2 plus 3, 5 into 3 should give us 15. Let's see how it works. And that's it. It does give it 15. Perfect. Now let me switch things up a bit and make it a bit more complicated. Let's add into 3 and let's add 5 into 3. What do you think will be the output here? Take a moment, pause the video and try to figure out what could be the possible output of this equation. Well, it'll calculate the brackets first. So 2 plus 3 is 5. Then multiply into 3 into 3, 9, right? Plus 5 into 3, which is 15. So 5 into 9, 45, plus 15. So it should give us 60, right? Let's see what it gives us. And perfect. And that's how you can work with an Excel formula, and that's how it evaluates it at the back end. What I want you to do here is I want you to practice this as much as you can. Honestly, you'll get the hang of Excel formulas the more you practice. So go ahead, experiment with this, use as many operators as you can, try to make it as complex as you can, and that is how you'll understand how to evaluate these formulas. Here, I'm going to talk about cell referencing techniques, a concept you'll be using a lot in Excel. So what is a cell reference? A cell reference means the cell to which another cell refers in Excel. So there are, broadly speaking, three types of cell references. The first one, probably the most common one, is a relative cell reference. This is when we copy a formula, the row and column index of the reference cell changes. As you can see in this particular slide, as the formula is being copied downwards, E2 becomes E3 and becomes A4 and so on. That's a relative cell reference. Second is an absolute cell reference where neither the row index nor the column index changes. We use the dollar sign to freeze both these things in place. And don't worry, we'll see all of this in Excel soon. Finally, we have the mixed cell reference where either the row index or the column index changes when we copy a formula. Let me head over to Excel and show you all of these cell references and how they work. Alright, so we have the employee salary and payout data set here. So in the previous video, when we were calculating the sum, we saw it till this payout column, right? Now we have the increment percentage column as well. And we need to calculate the total payout after increment. So we need to calculate from H5. So the formula to do this is, and you can copy along with me as I do this, is equal to the payout, which is F5, plus again F5 into G5, which is the percent increment. So payout plus payout into percent increment, and press enter. Alright, now you can either press Ctrl C or simply drag this down to the last row. And as you can see, what's the formula bar as I go downwards? F5 and G5 will become F6 and G6, F7, G7, and so on. This is a relative cell reference. Relative because the cell address is changing with the position, right? F7 becomes F8, becomes F9, and so on. But here a note of caution. If you copy and paste this formula into a different cell, let's copy it to L7, see what happens. It becomes 0. Why? Because what's the formula? It's taken J7, which has absolutely no values, and K7 again, no values here. And this is because it's a relative cell reference. The position has changed with relative to the formula that you've copied. So keep this in mind. To avoid this situation is where we use absolute cell reference. Right now, we need to calculate the bonus for each employee in the company. When the company has announced a bonus of 10% that has to be given to each employee. To calculate this, put the formula H5 into E2 and press enter. Alright, so bonus for employee ID 8001 is 844. Let's see what happens if I just drag this down to the last row. Employee number 2 has no bonus at all, and there's an error for the third employee and then absurd values after that point. What do you think went wrong here? Well, right now Excel took this as a relative cell reference. So it's taken E3, which has no value. E4, which is the column name, it's a string data type, so obviously you can't use that in an Excel formula. And after that, it's taking the travel allowance E5, E6, E7, and so on. This is not how to calculate the bonus. We only need E2 to be frozen in place, right? So this is where absolute cell referencing comes into play. So use the dollar sign, freeze all the columns and indexes in their place, and just drag this down. Again, didn't quite happen. What do you think I went wrong here? Well, you don't need to freeze H5 in place, right? Because payout has to change. Only E2 has to remain the same. So just remove this, press enter, and again drag this down, and perfect. And as you'll see as I scroll down was the formula bar. The payout after increment column keeps increasing relative to the H column, and E2 is frozen in place. And that's how you use absolute cell referencing. Finally, whenever you only need to freeze either the row or the column index and keep the other one relative, you use mixed cell reference. So let me name this total, and let's say the company is giving a fixed bonus of 1000 rupees to each employee. So here, all you need to do is, since we're only using the H column, you can freeze the column, not the row. That's a mixed cell reference. Plus, let's say I only want the bonus, right? It's only the H column, so we'll let H remain as it is, and we'll freeze the row here since H2 is the only one we are referencing, and just drag this down, and there you are. Was the formula bar again as I scroll down, and you'll see the column is frozen, the row is not, right? That's a mixed cell reference. So go ahead and practice this as much as you can in your own machines, because cell referencing is something you'll be using a lot when you're working in data analysis in Excel in industry projects. So the more you practice, the more you'll learn. In the next video, we'll take a quick look at the pay special function in Excel, which, as you can imagine, relies on the formula aspect that we have discussed in this module. In this video, we'll discuss one of the most frequently used features of Excel called pay special. This pay special command is in almost all Microsoft Office applications, but Excel users probably use it the most. We can access this paste special command after copying cells. Basically, we use it to copy and paste cells, right? But it's a little bit more nuanced than that, and we'll see that in this video. So how do we access paste special? Well, there are multiple ways to do this. So just copy any cell, let's say A3, and you'll see this paste command has suddenly come alive. Click on this drop down menu and you'll see different options to paste your cell content. Who ever thought there'd be so many options to just paste a cell content? It's amazing. Another way to bring this up, and which I personally use, is through keyboard shortcuts. So just press Alt, E and S on your keyboard and you'll have the paste special menu right in front of you. As the name suggests, paste special is used to paste a value with various available options. Like, do you want to paste the formula? Do you just want to paste the value? Do you want to copy the format, validation, comments, notes? Do you want to also copy the column width along with the cell contents? We can also perform mathematical operations using paste special, like addition, subtraction, multiplication, division. And the most important feature, most crucial feature, which I've seen a lot of people don't know about this, is that you can transpose the copied values from rows and paste it to columns and vice versa using paste special. Let's do all of this and see how it works. Alright, so in the total payout column, which is basically our column H, we have a formula, as you can see in this formula bar, to calculate the total payout, which is G2 into F2, basically pay per hours into number of hours. What I want you to do is first copy the total payout, right? So let me just copy H2 for now. Press Ctrl C on your keyboard and let's just go to, let's say, O3. And how do you paste special? Remember, Alt, E and S. Right now, I just want to copy the value. So just click on value, press OK. And as you can see, 656 is copied here. Now you might be wondering, why paste special? Why can't you just copy paste it like a normal command? Let me show you why. Just copy this, and if you paste it here, just press Ctrl V. You'll see it's 0. That's because, remember relative cell referencing we saw in the previous video? That's exactly what's happening here. So remove this, and again Ctrl C. Go here, press Alt ES, click values, and click OK, and there you go. If you want to paste the same format as well, again keep copying it, Alt ES, and you can just select format and click on OK, and it will copy the same format that's available in cell H2. Similarly, if you want to copy the column width, so whatever is the width of column H, and I want to see that in column O, again Control C, go here, Alt ES, select column width this time and click on OK, and you'll see the column width of column O has increased to reflect the same one as column H. Similarly, you can try out all the other options that are available under paste special and figure out how it works. Next, I want to show you how to perform mathematical operations with paste special. So in J3, let's put a value, let's say 2. In the next cell, let's put 4. Now, copy 2 here, go to J4, press Alt ES on your keyboard, bring this up, and let's click on add. Let's see what happens. Okay, and as you can see, in J4 the values increased to 6. What has happened here is, by using paste special, we've added the value of J3, which was 2, to the value here, which was 4, and which brings up 6. Let me solidify that concept once again. Press, since this is already copied, press Alt ES again, bring this up, let's subtract it. Let's subtract 2 from 6 and we'll bring back 4. It's really that easy. You can go ahead and try out the multiplication and division options as well. Now comes a very interesting part. You're going to transpose the total payout columns to rows, right? What I want you to do is copy this entire range, select it, press Ctrl C. Let's go a little down. Let's go to D20 for example. Here, press Alt ES on your keyboard, select values, since we want the values to be posted. Now tick transpose, right? And now let's click OK. And there you go, voila! Your total payout column is now in row. 20. The entire column is now in rows. Perfect, right? And just to give you an idea of how to transpose it back, how do you get a column from this? Copy the entire row, go here, press Alt ES on your keyboard, values, transpose, click OK, and there you go, it's back to columns again. That's how effective and useful it can be. This is especially useful for my personal experience when I have a ton of values in my rows and I just want to bring them all together in one column in one view. So this is where transpose comes in very handy for me. And finally, before we wrap up the video, I want to show you a different kind of page special called the format painter. When I want to basically copy the color of different cells to some other cells, a format painter comes in very handy. So let's make this row 4 a different color. Let's make it a golden color. Now I want the row number 8 to be golden as well. So what I'll do is I'll select all of this, use the format painter and just click here, and there you go. And I'll teach you a trick that a lot of people don't talk about is you don't just have to do this one by clicking format painter again and again. So let's say I want to do multiple rows. I want multiple rows in golden color. What I'll do is I'll double click format painter and whichever rows I want, let's say I want 11, 13, 15, 16 all in golden. That's it. Just one click and the entire color is being pasted again and again. It's really that easy and you can just untick it to remove it. Perfect, right? So that wraps up our module on getting familiar with the basics of Excel formulas, how cell referencing works and how to use the paste special feature in Excel. In this video, we're going to talk about the various date and time functions that Excel offers. These functions are useful to return information about dates and perform manipulation with date and time. And that is something you'll be using a lot when you're performing various analytical functions. And you'll actually find that you're working with date and time features a lot in your professional career, especially when you're working in Excel. And this is something I personally feel every analyst should have a handle on. So let's get into it. So by the end of this video, you learn about the various date and time functions like day, year, date difference, end of the month, hour, network days, etc. You learn how to collect information about date and time. You'll also learn how to perform manipulation with dates and how to find the difference between two dates, such as how do you find the difference between 2 years, different months, different days, and so on. So let's first discuss how to know the current date and time. There are primarily three functions: now, date, and today. So now, as you can see, returns the current date and time. The today function returns today's date, including the hour and minute, and the date function returns the date from a user supplied year, month, and day. And you can see the syntax here. And don't worry, you don't have to memorize this. We look at this in Excel in just a quick bit. Next, how do you basically extract information about a date? These are the functions you can use to do that. You have the year, day, month function, the hour, minute, second, very self-explanatory functions. The weekday function basically tells us what day of the week is it using a numerical figure, and week num similarly tells us what week number this is in the particular year. So it goes from 1 to 53. And these are the syntaxes to do it. Again, we'll do this in Excel quickly. So let me just jump over to Excel and show you how all of this works. All right, so we have this sheet here prepared. So to calculate what date and time it is right now, the formula is very simply is equal to now, brackets open and close and click. All right, so it's 18th April 2020 and 1:46 right now while I'm recording this. And that is a very easy way to find out the date, month, year, and time right now. And if I want to find out what date or day it is today, just is equal to today, open close brackets, click, and it shows me what date it is. It's 18th April 2020. Finally, if I have all of these numbers, all of these dates in different cells, all I have to do is I have to use the date column. And as you can see, Excel helpfully offers me the tooltip. So the year is 2020, select that. Month, selected. And the day, selected. Bracket close and there. So when you're working with different dates, you don't just want to find out the date today or right now. This is how you can use the date function to do it. Right, next, let's look at how to extract information about date and time. All right, so I've already inputted the today date here. So let's extract information from it. So how do you figure out the year? Is equal to year. Very simple. Select the cell, press enter. It's 2020. Month, again, open, select the cell, press enter, there you go. And I'm sure you're getting the hang of this already. Day, select the cell, enter, it's the 18th. R, select the cell, and we have a issue here because I did not close out the formula. Click R, select the day. Now, interestingly, it's showing me 0 here. Well, that's not quite true. It's not midnight while I'm recording this. That's because the formula we've entered is today. Today does not record the minute by minute. It just gives us the date. So if I use now here, let's see what happens. And as you can see, the R has been updated accordingly. And to calculate the minute, just use the minute command, select it, press enter. It's the 40th minute. Right now it's 1:48. To calculate the second, again, second, select the date, press enter. To calculate the week number, so go for week num, select this. So this basically tells me what week of the year this is. The 16th week in the year 2020 right now. And the weekday similarly tells me what number day this is right now in this particular week. So Excel calculates the start of the week from Sunday, and I'm recording this on a Saturday. That's why you have 7 here. Now let's apply some of these key functions in an actual data set. So here we have some information about an employee, like his or her date of joining, what time a particular sale was made, the number of hours people, and so on. So here I want to extract the number of the week, which day of the week is this, and the year. So I'm going to use the DOJ, date of joining column, to get all of this information. So to calculate the number of the week, remember the formula? It's week num, that's right, week num, select this, close it out and press enter. So this is the 24th week of the year 2012 when Anil Kumar joined. And you can just copy this down and you'll get the number of the week for all the other employees in this data set. Next, which day of the week is this? Basically, which day did the employee join in that week? Again, weekday, select the appropriate cell, press enter, and you have the day of the week. And just copy it, paste it. And as you can see, we now have the information about the week of the joining of each employee. You might be wondering, why is this required? I mean, why would I even need the day of the week or the number of the week? Well, think about it from an HR's point of view. They are heavily involved in things like recruitment, onboarding, and so on. And they want to understand the different underlying patterns. So the day of the week will tell them, okay, we employed or we onboarded or we recruited these many people on this day of the week. So what does that tell me? Are we doing this right? What day of the week is getting overloaded? Can I basically segregate this across the other days of the week, and so on? So this is very helpful for different departments. So you need to understand whichever organization you're working in, whichever department you're working in, these kind of things you need to think from a business perspective. Finally, to get the year, we've already seen this, very simple, year, select the date, and there you are. The date of joining, the year of the joining is there, copy paste it, and we have it, perfect. Let me head back to our PowerPoint presentation. And now I'm going to show you how do you manipulate dates? How do you basically find out different things, different information from the dates that you have? So there are three functions primarily that help me do this. Slightly more advanced aspect of the date time function. So we have EO month, which is the end of the month. It basically returns the last date of the month shifted by the given number of months in both the forward and the backward direction. Don't worry if that sounds like a mouthful. I'll show you how it works in Excel and you'll get a better understanding. Another function is the date diff function. It basically returns the difference between two dates, the number of days, months, or years, whatever you want. And finally, we have network days, which returns the number of network days, which are business days between two supplied dates. Let me head back to Excel and show you all of these, how all of these functions work. So let's open up our manipulation sheet. All right. So here we have the advisor code. We have the license issue date for the advisors and the license expiry date. Now what I want to do is I want to send, let's say, an email to the advisor letting them know at the end of the month that the license has expired or is expiring in that particular month, right? So we'll use the EO month function to do that. So let's see it in action. It's EO month. Our start underscore date will of course be the license expiry date. And since we want to send the letter at the end of that particular month, we'll put 0 here and press enter. And as you can see, we get the last date of that month. If I wanted to get the last date of the following month, all I have to do is replace 0 with 1, press enter, and as you can see, I have the last date for the following month. In case I want to send a letter or an email in the preceding month, then just replace 1 with -1, press enter, and there you go. And that's how you can play around with the EO month function. Drag this down or copy it to the cells remaining, and there you go. So you have the EO month for all the advisors in your system. Next, I want to figure out the vintage in years for each advisor. So how do we do that? This is where we'll use the date diff function. So you can follow after me. Date diff the license issue date. Let's say we want the date difference from today itself. Let me remove the inverted commas, right? And we want it in years, right? So put y in inverted commas and hit around of okay. There you are. So the vintage in years for advisor A001 is 7. And again, you can just drag this down or copy it down. And there you go. So that's how you can use the date diff function to figure out the vintage in years. If you wanted vintage not in years but in months, all you have to do is replace y with m and you'll get the vintage or the date difference in months. If you want it in days, you can just replace m with d, and that's how you can do it. I'll just revert to y again since that was the ask for us. Not just that, it gives me the business days. So by default, network days, the function network days, which I'll just bring up for you here, removes the weekends when it calculates the difference between two dates. So start date is 1st August. Let's say the end date is 30th September, and just close it out for now. There you go. As you can see, it should have been 61 days. That's the difference. But network days has removed the weekends, and it shows me that 43 working days or business days are available between these two dates. And if you have a list of holidays like I have here, you can include that in networking days as well. Do this, just go to the formula bar, comma, select the range of the holidays and press enter. And there you go. You have 40 business days in between 1st August and 30th September. Why is this useful? Think about it from business's point of view. They quickly want to analyze how many working days are available between in a year, in a couple of years, in 5 years. They want to understand how much an employee has worked, for example, and all sorts of things. Very helpful when you're in the HR, if you're in finance, and so on. All right, so this was a very solid introduction and a broad overview of the various date and time functions that you have at your fingertips in Excel. Go ahead, experiment with it, play around with it, and practice it. In this and the next few videos, we're going to talk about the various text functions that Excel offers. Real world data sets, when you're working in the industry, you'll often have a ton of text features that we need to manipulate and wrangle in order to get insights. As an analyst, you need to understand how Excel can help you quickly navigate and pass these text functions so you can go ahead with your analysis part. Think of features such as gender, region, city, state, name, product name, and so on. All of these are typically text features, and Excel helps us deal with them using the text functions that we'll soon see. So in this particular video, what we're going to do is we'll get familiar with the functionality of these functions, and then we'll hop over to Excel and then see how they work. So we'll discuss text functions like left, right, mid, replace, substitute, find and search, and others. What these functions help us do is they help us perform manipulations with text data, like how do we join multiple cells that have text? How do we extract text from those cells? How do we collect information about those texts, and so on? Honestly, there are a whole host of things you can do. So what are the names of these functions? Well, the first three that we look at are left, right, and mid. We typically use these to return characters from the beginning, the end, or at a particular position of a given text. And as you can see on this slide, this is the syntax. Don't worry about memorizing this. We'll see it in Excel very soon. Just understand that left function basically lets us extract text from the left of the cell, right, as you can imagine, from the right of the end of the cell, and mid basically helps us extract from a given position, a customized position that we input. So let's head over to Excel and see all of these three in action. All right. So here we have a data set of again of the employees, and we have their date of joining, how long they've been their department, number of hours they put in, what's their pay per hours, and so on. And of course the employee code. So we'll primarily be working with the column number D, the name for this particular video. So let's see the three functions in action. So let's input left. So as Excel tooltip tells us, input the text, which is basically D4 for us. And how many characters do you want to extract from that cell? Let's go with 4. All right. So what will happen here is the left function will start from A. That's the first position, and it will extract the first 4 characters from the left of that cell content. Let's click enter, and as you can see, we have Anil extracted. Just copy this or drag and drop this downwards, and that's exactly what's happening everywhere else. So look at this, for Preeti Kaur, the first 4 characters are PRW, right? And that's what's been extracted here. That is essentially how the left function works. Let's see the right function in action next. So again, right text, of course, is the same D4. And how many characters do we want to extract? Let me go with 5 this time. Press enter. So what do you think happened here? Well, Excel took the last position of the text or the string and took the last 5 characters. So RAMUK, basically Kumar is here. So just copy it or drag it down. And as you can see, the same results have come for the rest of the column D names. So if you look at Ayushi Sharma, we have the last 4 name HARMA here, and that's essentially how the right function works. Now comes a very interesting function called mid. So let me first show you how it works. So text again is going to be the same. Now start underscore num. Basically, where do you want the starting character to be? It doesn't have to be the first, doesn't have to be the last. So let's go with 5 and see what happens. And how many characters do you want? I'm going to say I want 6 and close it out. Let's see what happens. And let me just copy it before I explain how this function. All right. So if I take Tavish Srivastav here, for example, you can see the output of the mid function is sh space sre, right? What happened here? Well, we mentioned that we want the 5th character as a starting point. So let's count it. 1, 2, 3, 4, 5. So S is the first character where you'll start from. And we want 6 characters starting from that point, right? So sh space sri, and that's exactly what the output is. That is essentially how the mid function works. Now, here's the interesting part about the mid function. It can also work like the left and the right function. How? Let me show an example in the same case. So if I wanted to function as a left function, I will just input the start underscore num as 1, and the number of characters I'll just, let's say, 6. Press enter, and you can see the first 6 characters of Tavish Srivastav have shown up here. That's basically how the left function works, right? And to make it function as a right function, this can get a little tricky, so just pay attention when I'm doing this. We'll let the cell number remain the same, D10. The starting number will be len, which is the length of the same cell, minus 1. And let's say I want, and let me just correct this. Let's say I want the last 2 characters only. Let's see what happens. And as you can see, it gave us the last 2 characters of the cell D10, which is Tavish Srivastava. We just have VA right at the end here. What is len? Len is basically the length. Length tells us the number of characters in that particular string, right? We'll talk about length just in a little bit in this video, but just for your information, this is how you can use the mid function to work as the right function as well. Go ahead, try it out on your own machine. Play around with the length, play around with the number of characters you want to extract. All right, let me head back to the slide. Yeah. Then we have the len and the concatenate functions. Len, as I just mentioned, returns the number of characters of a string, and concatenate essentially joins multiple strings or text in one string. Very useful, as we'll see. Let me head back to Excel and showcase how this works. So let's head to M4. All right, let's first see the length in action. So len, I want the length of the entire name. As it says, it gives me 10. Let me just copy this and drag it down. All right. So for example, Let's take Ankit Khanna. It says 12, but if you calculate the letters, those are 11. Why 12 length? Because len also takes into consideration the space between the strings. So the length of this particular string is 12, and you can calculate for the rest of the names as well. For Preeti Kaur it's 11, for Tavish Srivastav it's 17, and so on. That's essentially how length works. And concatenate, as I mentioned, joins multiple strings. It's very interesting function. So concat was the text we want. I want Anil Kumar. And let's say I want in this particular cell to show which department that person works in, right? So comma, and let's select department, which is G4, and press enter. As you can see, we have concatenated both the strings. Now, of course, it's there's no space there. So let's add that. Let's see how to do that. Concat, all you have to do is inverted commas open, give it a space, inverted commas close, comma, and enter. And there you go, you have space there. And you can always enter some text in there as well to showcase what is the relation between the two strings that you've concatenated. So let's say Anil Kumar works in, give it a space, admin. So as you can see, Anil Kumar works in admin, and copy paste this. And as you can see, it's populated the rest of the cells. So Amit Kumar works in sales, Kunal Jain works in support, Deepak Kumar works in admin, Ayushi Sharma works in HR, and so on. Very useful function. A lot of people these days prefer using the ampersand sign instead of concats. Let me just show you how that works too. So instead of concat here, all you have to do is Anil Kumar and admin. So G4, enter, and there you go. And to get a space again, you can do the same thing, ampersand again, enter, and there you are. That's how the ampersand works. So you can choose toggle between concat or ampersand, whichever you feel comfortable using. Now we will discuss functions that help us to find the starting position of a search string inside a string. By default, these functions search the string from the first position, but we can honestly search it from a specified position as well, although this is an optional argument of that function. Here's a look at the syntax of the find and search functions that we'll just be seeing in Excel. Again, no need to memorize them, we'll see them in action in Excel. Just know that these are the two functions we typically use to find and search for a particular string or a part of a string inside a given text. One thing to keep in mind, find is case sensitive whereas search is not, and you'll see that major difference popping up in Excel in a bit. So let's head over to our Excel sheet. Alright, so here we have the candidate ID, the name of the candidate, and what skills that candidate possesses. So each candidate has a particular set of skills which is listed in this column. Right, so what we need to do is we need to use the find and search functions to locate Python, machine learning, deep learning, and Tableau search terms inside column number E, the skill column. So let's get going. Let's start with the find function. So is equal to find. Again, a very helpful tooltip from Excel. Find the text. What exactly do we need to find? So here we obviously need to find Python, comma. Where do we need to find it? Is in this cell E4. And start num is essentially from which position in that particular cell do we want the text to be found. We don't need it right now. So let's close the bracket, press enter, and there you are. One means that Python is found at the very first position in this cell. That is what the find function has done. Let's just drag this down. And as you can see, Python, wherever it's present, it's only present at the first location. And this error essentially means that Python is not present in that particular string or cell. And as you can see, it is not present here, right? There's no Python here, 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 or here. So it makes sense that the error is coming up. Similarly, let's do it for machine learning. What do we want? We want machine learning to be found. In which text? Of course, in E4. And let's close it out. And we have an error. Let's deal with that. Let's just drag this down. Interesting. I'm getting an error in each cell here. Why do you think that's happening? This is because if you'll notice, machine learning has the L in lowercase everywhere. Here, if you'll notice here, wherever machine learning is input basically in column E, it's in lowercase, especially the L. And whereas we are searching for L in uppercase. And as I mentioned when we were looking at the slides, find is case sensitive. That's why you're getting an error everywhere. This is where our search function comes in handy. Let me show you how. So let's use the search function. What text do we want? We want deep learning. And here again, I'm capitalizing L, even though L is in lowercase everywhere in our data set. Deep learning, where do we want it? Of course, in E4. Let's close it, enter. Let's drag this down, and you can see here, even though deep learning is in all in lowercase and we're searching for it in uppercase, especially D and L, the search function has still managed to find it. And 28 means that from the starting of the string, basically from S here, deep learning is located at the 28th position. That's what this is telling us. Let me replace find here with search, and you'll see how it works. And there you go. You can clearly see that the search function has worked where the find function did not. And machine learning in E4 is available at the 33rd position from the start. That's basically how the find and search functions work. And to give you an idea of what the from command or argument does, so let's just put in start underscore num. So where do we want the search to start? By default, it starts right from the first position. But let's say I want to start it from the 34th. Let's see what happens. I think there are two brackets. Let's close one. There we go. So there's an error. And if I turn this into 33, you'll see that it is able to locate it. Now that is what the final argument, the from or start underscore num does in the find and search functions. All right, and let's search for Tableau as well. So what do we want? We want Tableau. Again, we want it here. And just to show you how it works, let me say it available from the 37th position, for example. It's still available, not an issue. And when we populate all of the other cells, you'll see that Tableau is available here, but because we wanted to search from the 37th position, it's not available beyond that. That's why it's giving us an error, right? If I remove this, you'll see that Tableau will be found at the 34th position. So that it gives you an idea of how the find and search functions work. All right, let me head back to the presentation again and show you a few other functions that work with text data. Very simple functions these, the upper, lower, and proper functions that, as you might have intuitively guessed, convert the text into uppercase, lowercase, and proper case. In proper case, the first character of each word becomes capital. Let me head back to our Excel sheet and show you how all these three work. Okay, let's say D19. Let me pick up any cell. Let's say Amit Kumar. So that's D5, right? So input upper D5, press enter. And as you can see, this string or text is now in all uppercase. Let's convert it entirely into lowercase. Lower, let's just select this cell itself. And there you are. And finally, let's convert this into proper case. Select the lowercase one, press enter. And as you can see, the first letter of each word is now capital. That's what a proper case is. Fairly straightforward stuff there. And I mentioned that find is case sensitive, right? You can imagine how these upper, lower, and proper case functions can help us when we are working with the find function. So here we're going to focus on the replace and substitute functions in Excel and how they help us work with text data. So replace and substitute functions, as you might have guessed from the name itself, are used to replace a certain part of a string with a new string. So if you look at the syntax of replace that I've shown here, it is used to identify an old string. It is used to identify an old string based on the position and the number of characters, and we replace it with a new string, whatever we want. Whereas in the substitute function, we replace an old string with a new string. And we also have the option of using an instance. Don't worry if this looks like a handful. We'll cover this in Excel in just a bit. Couple of things I want you to keep in mind is that the replace function allows us to swap one or several characters in a text with another character or set of characters, whereas the substitute function replaces one or more instances of a given character or text string with a specified character. Substitute also asks for which occurrence we want to replace, and just keep this in mind, it is case sensitive. So to summarize, if you know the text to be replaced, use the substitute function. If you know the position of the character to be replaced, use the replace function. Let's head over to Excel and see both of these in action. Alright, so we have this data set with us. We've seen this earlier, except this time we also have an email ID column. And that is primarily what we'll be working with in this video. So here the ask is that the organization has decided to convert the .com to .org due to a legal reason. And we need to make this change in the database. This is where we'll use a substitute function because we already know the string to be replaced, right? So recalling the syntax, let's do that. So substitute was the text we have, that will be E4, right? What's the old text? It's .com. The new text is .org. And for now, just close the bracket. And there you are. You've replaced .com with .org using the substitute function. Now you can copy and paste it in the other cells or just double click. And there you are. You've successfully used the substitute function to replace .com with .org in the entire database. Perfect. Another wonderful use of the substitute function is that there might be times when we have a typo in the data set and we quickly want to make that substitution, or we want to basically correct that, right? Again, the substitute function comes in very handy. For example, let's take D4, Anil Kumar. Now, this person's actual name, for example, was Anil Sharma, but due to a typo when we were entering the name or when the name was being entered, it was Anil Kumar. We want to replace Kumar with Sharma. So how do we do that? Very simple. Substitute. We want to replace this. The old name was Kumar. The new surname is Sharma. Close it out, and there you are. You have the new name. Perfect. All right, let me show you a very powerful example of the substitute function again. Let's say in our data set, we have the name Sunil Kumar Verma. So here there's a typo. The second instance of Verma was supposed to be Kumar. How do we make the replacement? Again, the substitute function is our friend here. The text, of course, is this. The old text is Verma. The new text is Kumar. Now we have two instances of Verma. This is where substitute function helps us. Just enter 2 because we want the second instance to be replaced. Enter, and there you are. Sunil Kumar Verma is now converted to Sunil Kumar Kumar. Perfect. And that is how you can use the substitute function. Alright, let's head over to our replace function now. Here, now the organization has decided to get everyone under the same domain. Right now you can see we have XYZ, RYIF, XYZ1, YOO, XYZ2 and so on. There are all sorts of domains there. We want everyone under the same domain. How do we do it? First, let's just see a basic example of the replace function. So replace, I'll use I4. What is the starting number? Let's manually count it. 1, 2, 3, 4, 5, right? And 6. So the start of the domain is from the sixth character. So let's input 6 here. How many characters do we want? We want 3, and we want to replace it with ABC because that's the name of the new domain, and click enter. Alright, as you can see here, we have replaced xyz.org with abc.org. Perfect. But now you'll see why this isn't the best strategy. So just drag this down. There is some sort of error. Excel is not giving an error here because it does not understand what exactly we're looking for. But the at the rate has disappeared from most of these. In fact, all of these. What went wrong? Take a moment to think about it. You can pause the video, just pass through this function and try to understand what went wrong. Why are we not getting the result that we were looking for? Did you get it? Well, what we did was we manually calculated how many characters were required as the starting position, right? So here it's 6, but here it's actually 7. Here it's 7, here it's 7, and so on. And since it's manually taking 6, look at the formula bar, it's always 6. That's why at the rate has disappeared. And we're getting an absurd email ID, which is not really even an email ID. So we need to make a few tweaks before we can use the replace function. So this is the strategy we'll follow. First, we'll use the find function to locate at the rate in this cell. Then we'll locate .org, and then finally we'll use the replace function to make the replacement. What we're doing here basically is we're trying to find the position of the domain name by locating at the rate and .org. And as you can see, the domain name is between these two, right? So that's how the find function and the replace function combine to help us. Let's see it in action. And let me just rename this column to position of at the rate, position of dot, since that's what we'll find. And finally, we'll call this replace underscore new, right? Fine. Let's now find the @ sign here and just press enter. Okay, it's at the 5th position in this cell. Perfect. Just drag this down and we have the position of @ for each cell. Let's find where the dot is. Again, the find function, we're looking for the dot and we're looking for it in I4. Enter. It's at the 9th position in that cell. Drag it down and we have the position of the dot as well in each cell. Perfect. Now we can finally head over to our replace function. So here we go. Replace, select the cell we want the content to be replaced for. What is the starting character? It's this +1, right? Because we don't want to replace and, we want to replace the character after and, so that's why +1. The number of characters we want to replace, well, it'll be the position of dot minus the position of @-1. That's it. And we want all of that to be replaced by ABC. Enter, and there you are. Just drag this down and perfect. You've successfully managed to use the replace function to change the domain name of all the folks in your database. And that is how you use the substitute and replace functions. Here we'll be talking about the text and value functions. These are very straightforward functions as you'll see. The text function essentially converts a number to a given format. We use it to deal with text output that is not in the user's preferred format. As you can see in this syntax, it's just text, that's the name of the function, the number and the text format you want it in. And the value function, on the other hand, we use it to convert a text string to a number. Right, and the syntax very straightforward. Value, the name of the function, and the string that we want to convert. Really that simple. Let's see both of these in action in Excel. So let me switch over to Excel. All right. First, let's see the text function. Let's say I want to show the current date at the top of any dashboard that I'm working with in Excel. So instead of manually having to put it in, for example, this cell, this report is as of 9 April. So if you do this every day or whenever you send the dashboard or the report, you have to update the date manually. Why not automate this? So let's do that. First, let's put today's date, press enter. All right. Now let's automate this. Is equal to this report is as of, give a space, use the ampersand. Now follow after me, text. What's the value? That will be A1, today's date. And what format do you want the date in? So let's go with D, MMM, and YYYY. So I'll replicate the format that we see here. Press enter, and there you are. You've automated the entire cell, and you don't need to ever update the date again in your dashboard. Really that simple. Next, let's see the value function in action. Let me input any number. Let me say 1, 2, 3, 4, 5 here. Alright, so I'll just convert this to text to show you how it works, right? So as you'll see an error here, this says number is stored as text. This typically happens when we are importing a CSV or a TXT file and we want to convert this into a number because that's essentially what it represents. This is where we use the value functions. Just say value, select the cell, press enter. And as you can see, this cell which contained a number in text format is now in a numbered format. And that is basically how text and value functions work. And that brings us to the end of this particular module on date, time, and text functions. Go ahead, practice all of the functions that we've covered, do all the exercises in this course, and that's how you'll pick up all of these little things and become better at them and eventually master them. And this module on mathematical functions, things are just starting to heat up and get very interesting. So in this and the next video, we will discuss mathematical functions like sum, product, round, SUMIF, square root, among others. What these functions help us do is they help us perform basic mathematical calculations and even some advanced ones. So we can round the number by the nearest integer, or we can add values based on single or multiple criteria, very useful thing. And we'll do a whole host of other things as well. So in this particular video, we'll be focusing on these mathematical functions like sum, product, square root, mod, and factorial. And these work exactly how you would expect them to in mathematical terms. So sum adds all the numbers given as an argument, product multiplies all the numbers that you give as an argument, SQRT calculates the square root of a number, mod returns the remainder, and fact returns the factorial of a number. Let me head over to our Excel sheet and show you how all of these functions work. Right. So here we have a certain employee information for an organization. We have the unique employee code, their date of joining, how long they've been with the organization, gender, department, number of hours, and paper hours. What we need to do is we need to calculate the total payout for each employee. So the formula to calculate the total payout is, and let me just list this down here, is the pay per hours into the number of hours they've worked. Right, so that's basically column I and column H. And we can use the product function to do this. So type after me as I do this, product, the paper hours, which is I4 into number of hours H4, press enter, and there you have the total payout for employee code A001. And you can just copy paste this for the remaining cells, or just drag this down, and there we are. We have the total payout for each employee in the organization. You can of course also use the asterisk sign to calculate this, to multiply I4 and H4. So let me show you how to do that. I4 into H4, press enter, and there we are. So why use product then if we can simply use the asterisk sign? Well, this is because you can use asterisks when you have a limited number of columns to find the multiplication for. But when you're working on an industry project, a real world project, there are chances when you have multiple columns where you have to calculate the product for. So you can't manually input each cell number, right? That's where the product function comes in handy. Now, the next task is to calculate the total payout for the organization. And we've seen this function before called sum. All you have to do is type sum, select the entire range, and press enter, and there we are. We have the entire sum for the organization, which is 7417.29. Alright, let's see the other mathematical functions in action. So let's see mod first is equal to mod. Let me take a number 12. Let's say the divisor is 7. So this should give me the remainder, which is 5. And that's what we get. Let me show you how to calculate the square root of a number is equal to SQRT. That was the name of the function. Let's say you want the square root for 4, which should be 2, and that's what we get here. Finally, how to calculate the factorial of a given number. So the function is fact. Let's do it for 4 again. So remember how to calculate the factorial. It's basically 4 into 3 into 2 into 1, which should give us 24, and that's what we get. So in this video, we learned about some basic mathematical functions like product, sum, square root, mod, and factorial. Let's continue that theme and discuss even more mathematical functions in this video, such as how do we round a number to the nearest digit, or how do we perform sum when we have certain criteria that we have to take care of. So first, we're going to look at how can we round a number by a given number of digits or by the nearest multiplier. And we have various functions available to do this. We have int, round, round up, round down, ceiling, and floor. These are very intuitive. Int basically rounds a number down to the nearest integer, and you can see the syntax here. Round essentially rounds a number to a specified number of decimal places. Round up and round down, basically very simple. Round a number up or down according to whatever you prefer. And ceiling and floor, these are personally two of my very favorite functions. Ceiling is used to round a number upwards to the nearest multiple of a specified number, whereas floor is used to round the number downwards. Let's see all of these in action in Excel. Let me pull up our Excel sheet, and we saw this in the previous video. We'll build on that. I'm going to use the total payout column to work on all the functions that we just saw. Let's start with the integer function. So is equal to int. We'll select this cell and press enter. And as you can see, 695.25 has been rounded up to the integer 695. Right. Next, let me show you round. So round 398.75. That's the number we select. And how many digits do you want the number to round off to? Let me select 1. And there we are. So 398.75 became 398.8. Round up will essentially do the same thing that you'll see. So just select 1 again. And there we are, 387.25 rounded off to 387.3. And let me show you round down. So we'll select this, select 1, and there we are. Basically, round down, what round down did is rounded off the number to the previous number. So this, if I applied round up here, it would have been 595.8. Instead, it's 599.7 because I specifically mentioned to round down. And that is basically how all of this works. Now, let me move on to an example of ceiling and floor. Right? What these do, as I mentioned, is ceiling is used to round a number upwards to the nearest multiplier of a specified number, right? So let me take this example. So let me say ceiling. this number and round it off to the nearest multiple of 5. So this should give me 535, and that's what we get. Just take a moment, pause the video and try to understand what happened here. Similarly, if I use this and I use the floor function, we do this rounded off to the nearest multiple of 5, and we get 695 because we're going the other way here. Remember, 535, we used 5 as the significance, so it looked for the next nearest multiple of 5, which was 535. Here it looks for the previous multiple of 5, 695, and that is how ceiling and floor work. You can think of a car parking example where you have a limited number of slots and you quickly need to understand or round off a number to understand how many slots are available, how many slots are free. You can use the floor function there to quickly get the number. Go ahead, try it out on your own machine, and you'll see how useful this function is. Right, let's move to the next interesting mathematical function. And this is something I use a lot when I'm doing data analysis in Excel. So let me head back to the PowerPoint. SUMIFs. SUMIFs is a very useful Excel function that we use to add numbers based on single or multiple conditions. And this is the syntax. We basically give the range of the column that we want to first perform the SUMIFs on. What is the first criteria range? You input the column range here. What exactly is the criteria, which will come in inverted commas. Then if you have multiple conditions, this goes on and on until your conditions are satisfied. Let me head back to our Excel sheet and show you how this works. So I'll just unhide this. Remember how to unhide columns? Selected the multiple rows, right click on it, click on unhide, and there we are. So let me do one thing. Let me just decrease the width so you're able to see the entire column. There we are. So here we essentially have to calculate three things. We have to calculate the total payout of males of the support department and the total payout of females who are working more than 15 hours. So let's use SUMIFs and answer these one by one. So SUMIFs, what's the range? We want the payout, right? So that will be our first argument. What is our criteria range? We want male employees, right? So head over to the gender column, select the entire range. And what's our criteria? We want males. So put that in inverted commas, close the bracket and press enter. And there we are. We've calculated the total payout of male employees using SUMIFs. Let's now use multiple conditions, so multiple criteria. Again, SUMIFs. What is the total payout? So that will be a range. What's the first criteria? That it should be a male, right? So that's the first range you'll select. The criteria is male. Now follow a similar pattern to enter the second criteria, which is you want to find out the department support. Select the entire department column, that's our range, and our criteria is basically support. Press enter and there you are. You've calculated the total payout of males working in the support department. And finally, we want to calculate the total payout of females who are working more than 15 hours. Again, SUMIFs, payout is our range. Now first criteria is female, so again we head over to the gender column. Our criteria is time is female. Second criteria, of course, is the number of hours. So select that and working more than 15 hours. So greater than 15, close out the bracket, enter, and there we have it. Total payout of females working more than 15 hours. So this is very useful when you're working in HR or finance, when you quickly need to understand the total payout based on certain conditions. And SUMIFs helps us do that. In this module, I'm going to introduce you to the financial functions that Excel offers, a very relevant topic in the real world. So by the end of this module, here's what you will have learned. How financial functions are used to calculate information about financial products like loans, what's the return rate, savings, among other things. We learn how do you use common financial functions in Excel such as NPV net present value, IRR internal rate of return, FV future value, among other things. We'll also look at examples to help you understand how do you derive monthly payment against a loan, the EMI basically, or how do you calculate the future value against equal monthly savings, how do you understand or calculate the rate of interest, and so on. There's a lot to unpack in this module, so let's get started. First, I want to talk to you about the impact of time on money. Right? Let's say in 2020, I have 1,000 rupees and I offer you this 1,000 rupees in 2020. And I give you a choice that I'll offer you the same amount in 2023, basically 3 years from now. what would you choose? Would you choose, would you go with option one, 1,000 rupees in 2020, or 1,000 rupees 3 years later? Most of us would generally tend to go with 1,000 rupees in 2020, right? So this is what we call a present value, and this is what we call a future value. So keep these terms in mind: present value PV and future value F. This would be very relevant when we look at a few examples later in this module, and also when we head into Excel later. So keep these in mind. Right. Now let's say that you invest 1,000 rupees in a bank. You just put 1,000 rupees in a bank and you get an interest rate of 5%. A common occurrence, right? So now, what do you think the future value will be 3 years later, given your investment of 1,000 rupees at 5%? Right. So every year I get 50 rupees back as interest using 5% rate, and this means at the end of 3 years my future value will be 1150, right? Just adding 50 50 50 to my present value. This is a classic example of simple interest. I used 1,000 rupees as my present value, and using a 5% rate of return, that kept accumulating every year, give me 50, which led to a future value of 1150 in 2023. Now here's the question: is that how banks work? Is that how the real world works? Not really, right? Simple interest is a good concept to know, but it doesn't really apply to most scenarios in the real world. So now what's happening is, my initial present value of 1,000 at a rate of 5% will give me 50 rupees here, right? So I have 1,050 rupees at the end of the first year. Now I invest all of that in my second year, and will I get 50 rupees back? Repeat. Now I invest all of that 1,050 in my second year. So now my rate of return at 5% will give me a return of 52.5, right? Which means in the third year, I will add all of this up and invest my entire amount of 1102.5, which gives me a future value of 1157.63. This is a classic example of compound interest, right? Your money is compounding and accumulating year on year to give you a future value of what we just calculated. So if I have to put a mathematical formula to it, very simple: future value is equal to the present value. So present value is 1,000 into 1 plus interest rate per period, which is raised to the power of number of payment periods. So if I have to use this example, I'll just plug in the values, which will be 1,000 your present value into 1 plus interest rate per period, which was 5%, and all of this is raised to the power of the number of payment period, which was 3 years, and that is how you can calculate the future value. And as you can see here, our future value aligns with what we calculated here. So this is very basic introduction to what present value and future value are, what's the interest rate per period, what is the number of payment periods. Keep these concepts in mind. Let's look at another case study, which is a little above what we saw in the previous video, but it's more geared towards a real world scenario. Right, so here we have the question of, should we invest or should we not? Right, so I've used a simple cash flow statement where we have columns like year, cash inflow, which is the cash coming in, cash outflow, which as you can guess is the cash going out, and the net cash flow, which is nothing but the difference between cash inflow and cash outflow. Right, so a company has decided to initially invest 30,000. That's why you're seeing 30,000 in the cash outflow, and hence the net cash flow for the initial investment is minus 30,000. Fairly straightforward to understand, right? Now, each year, the company has a cash inflow of 10,000, a cash outflow of 2,500, and hence the net cash flow each year is 7,500, right? And that follows for each year, as you can see in this table. Now, I want to visualize this using a timeline so I have a better idea of how it's working. And this is how it will be. So my initial investment is 30,000 rupees. And every year, as we saw in this table, we have a net cash flow of 7,500, and you can see that's being represented here. So the question is, my initial investment of 30,000 after 5 years, what is it worth, right? So here the total return after 5 years will be 37,500. On the face of it, we can see we're making a profit on our initial investment. But is that 37,500 a good return? Because remember, this is after 5 years when the value of things changes, right? So we need to understand if this total return is worth the initial investment. Right now it looks that way, but let's see if it does. To do this, we need to understand, or we need to calculate the present value of each net cash flow at the end of each year, right? So the return at the end of year 1, at the end of year 2, and so on at the till the end of year 5, we need to calculate the present value of each of these returns individually. Now we know from the previous video that the formula to calculate the future value is present value into 1 plus interest rate per period to the power of number of payment period, right? Here we need to calculate the present value, correct? We know the future value, right? We know the future value for each year. It's 70 by 100, right? So here what I'll do is to calculate the present value, simple mathematical equation. It will be future value divided by 1 plus interest rate per period raised to the power number of payment period. Fairly straightforward. Now, when we calculate the future value, we call it the interest rate per period. But when the equation changes, when it's the present value, then we call it the discount rate per period. This terminology does matter, so keep it in mind. And when we sum up all of these individual present values, then we get the net present value or NPV. NPV represents the net cash flow throughout a project's life cycle discounted today. So if your net present value is positive, it means your initial investment was good. If it's negative, then you might want to reconsider your initial investment. It might not be worth what you think it might be. Let's head over to Excel and see how to calculate the net present value there. Right. So here we have the same cash flow statement that we saw in the slides. So we have the year, the cash inflow, outflow, and the net cash flow. And we have a discount rate of 10%. So we need to calculate the present value of our net flows for each year, and then we will calculate the net present value based on that. Right. So let's remember the formula. Let me head back to our presentation and show you the formula. Right. So the formula is future value divided by 1 plus discount rate per period to the power of number of payment period, right? Keep this in mind and let's do it here. So this will be E6 divided by power 1 plus my discount rate. Let's keep this as an absolute cell reference because you want to freeze it. And this will be your year, close the bracket, press enter. Right, I have missed a bracket here. Let me get that in, present. Right. So your present value of your net cash flow for the first year is 6818. Just drag this down or copy the cell down. And you have the present value for each net cash flow, and you can see it diminishing with each year, right? So what is net present value? Is nothing but the sum of your present values that you calculated. So that will be sum. Drag this down, F5 to F10, press enter, and there you are. So the net present value of your initial investment comes down to minus 1569. Given that it's negative, then it means that your initial investment isn't panning out the way you thought it would, right? So you might want to reconsider it. This is a manual way to, of course, calculate the net present value. Excel offers us a formula to do it. So let me show you that formula here is equal to NPV, the net present value. This is your rate. So that is, of course, our discount rate. Then value 1, which is nothing but your net cash flow value. And close this and it'll be plus your initial investment and just press enter. And you get the same net present value that we calculated here. So that is how you can use the NPV function in Excel. Go ahead and practice this because I understand this is a concept you might not grasp the first time. It's a slightly complicated one. So go ahead, practice it out. Find any financial data set that talks about cash values. You can use this one as well and see how it works out. Play around with it. Play around with the inflow outflow values, just change them to understand how the net present value changes along with it. Let me head back to the slide, and now I want to talk to you about a concept called IRR, or the internal rate of return. IRR is a metric that we use to estimate the profitability of potential investments. So the internal rate of return is a discount rate that makes the net present value of all cash flows from a particular project equal to 0. Right? IIR calculations rely on the same formula as NPV does. So we know the formula for net present value. So that's initial investment today plus future value divided by 1 plus discounted rate into the term period plus the same thing into term period, which will be 2 number of years, the third year, the fourth year, the fifth year, right? So the IIR, what it does, it basically gives us a discount rate that makes the net present value is equal to 0, right? The higher a project's internal rate of return, the more desirable it is to undertake. Just keep that in mind. And why internal? Well, that's because it does not take any external factor like inflation into consideration. So let me head over to Excel and show you how to calculate the internal rate of return. And this is very straightforward actually, thanks to Excel. So is equal to IRR, and your values will be nothing but E5 to E10, the range of your net cash flows. Press enter, and there we are. So we have an IRR of 8% for this particular project. I'll reiterate what this means. IRR needs to be 8% for the net present value to be 0. That's what this represents. And that brings us to the end of this particular video. Again, I'll reiterate, just go ahead and practice this. You can look out these concepts to further understand or deep dive into how they work in the real world. But just keep in mind that you need to understand the net present value, internal rate of return, present value, and future value, because these are very, very useful and very commonly used in the financial world. In this video, I'm going to talk about a few more commonly used financial functions and show you how they work in Excel. So let's talk about them. So here we have 5 of them. We have PMT, rate, NPER, FV, and PV. We already know what FV and PV are, right? Future value and present value. PMT basically returns the periodic payment. Think of it like calculating an EMI, for example. So this is the syntax of payment. The rate, NPER, is basically your number of periods. So that could be in months or years. PV, your present value, and this bracket means that it's an optional field. Future value, and type. Type basically tells me if you want to calculate it at the beginning of the month or at the end of the month. Excel takes end of the month by default, which is 0, and if you want to calculate it for at the start of the month, then you can type 1 here in type. Rate is the interest rate per period. NPER, as I just mentioned, returns the number of periods. FE and PV we already discussed. So let's head over to Excel and see how PMT, rate, NPER, and FE, just how they work. Right. So here, let's say we want to buy a car that costs $16,000. Right. That's the car value. The bank is willing to finance it at a 10% yearly rate of interest for 5 years. The future value is 0 because after 5 years we will settle the amount and the loan amount will obviously become 0. We need to calculate the PMT value or the monthly EMI. So how do we do that? We just saw the formula. It's is equal to PMT, right? So there are a couple of ways to get to it. Under the formulas tab in ribbon, you can go to financial and you can just scroll down and go to PMT, right? And Excel offers you helpfully, tells you what it is about. Or you can simply just type is equal to PMT. Now we know the rate is 10%. Since you want monthly, you need to divide this by 12, right? NPER is the number of payments. So select 5, number of years to pay. Multiply this by 12 because again, remember, this is monthly. Your present value is of course the loan amount, $16,000. FV, future value, it's an optional field. We'll keep it 0 as I just mentioned. And type, we want it at the end of the month, so just keep it to 0. The last 2 values you can leave blank as well if you want, and just press enter. Right, so here the monthly EMI for this amount comes out to be almost $340, right? And it's negative because this is going out of your pocket. That's why Excel tells you that this is a negative value and it's going out of your account. Let me show you another scenario. Here I have a range of rate of interest in number of years because I want to compare all of these different scenarios and understand the EMI for the same loan amount, right? What would it be at 7% rate of interest if the number of years were 3, 4, so on, right? And we can think of this as an EMI calculator. We'll use the PMT function again. So let's go ahead and do it. So is equal to PMT. Rate we know is this 7% for this particular example. Your number of payments will be of course the years there, 3, right? And your present value is of course the car value, $16,000. And I'll keep the last 2 blank because there's 0 for us. Now what do you think I'm missing here? This formula will work, but there's something that will go specially wrong if I just use this across the table. Couple of things. First, I haven't considered the monthly value, right? This will calculate the yearly amount. I want the EMI per month. So first, let's get that going. Divide this by 12 and multiply the number of payments by 12 because again, this is monthly. Next, we need to understand the cell referencing here. I can't just blindly copy paste it throughout the table because then it's gonna go haywire. I need to freeze a few things in place. Right, so let's freeze the rate column first. Put a dollar sign there. Next, let's freeze the number of years row. So put a dollar sign before 12 and let's entirely freeze the present value because that's going to remain 16,000 throughout. So let's freeze that. And now press enter. Right. So what is this telling me? This is telling me that my monthly EMI for a rate of interest at 7% for 3 years would be $494.03. Now you can just drag it across your table, drag it down, and now you have your own personal EMI calculator. How cool is that? You just used one formula, PMT here, to calculate the EMI, monthly EMI, and you just dragged it across, and now you're able to understand how the entire thing works. Perfect. Finally, I have one more scenario to show you, fairly straightforward at this point given how much ground you've covered. Here I have a monthly saving plan of 6,000 rupees for 10 years and it has an interest rate of 10%, right? So the question is, what is the future value? Couple of ways to do this, as Excel always offers multiple options. We can either use the formula we covered in the slide to calculate the future value. We've covered this before, right? Present value into power 1 plus the rate of return and of course the number of payments, right? And that's a manual way to do it. You can of course follow that for each value and then sum it up in the end and calculate the future value, or you can use the very simple formula Excel offers, which is FV, future value. What is your rate? That will be 10%. Number of payments will be 10, and we're not using monthly here because we're not calculating the monthly future value. We just want it together, no months involved in this case. Your PMT will be 6,000 and that's it. Press enter and there you are. You forgot one thing, is that your PMT value, your payment value will be minus here because it's going out of your pocket, right? Your yearly investment. So always remember to put a minus in front of it. Now press enter. Right, now the future value of your investment after 10 years, investing 6,000 per year would be 95,625 rupees. So that's how you can understand and use future value in Excel. That brings us to the end of the financial functions module. Go ahead, practice what we've learned. There's a significant amount of concepts that we covered, so it'll take you some time to truly master it, but the more you practice, the more you read about it, the more you do it in Excel, the better you'll get.
Let's look at very interesting set of functions, VLOOKUP and HLOOKUP. These are one of my personal favorites. So let's start with a case study. You are a marketing manager of an insurance company, First Insurance. You are expected to show a marketing plan to your management by end of this week. As a first step, to create this plan, you want to understand who are your customers and what are they buying. Which customers are buying what kind of products. How do you go about doing that? Well, you look at the existing data. So your existing data is available in three different data sets. The first data set has policy details. The second data set has customer details, and the third data set has product details. Now, in order to analyze this data set, you will actually need to combine these three data sets to form something like this, where you have all the values in a single table. How do you go about doing that? Well, let's look at it. So you have customer ID in policy details and a few other fields like product ID. This customer ID can be looked up in the customer details table. So in this particular case, the customer's name is Joe. He is a 33-year-old male who lives in London. You join the second table, product, with the product ID. So that's a protection product. So by combining these three tables, we get end-to-end information about the customer. So you now need to do this for the entire table. How do you do it? Well, this is where VLOOKUP and HLOOKUP will come to your help. So let's quickly look at their syntax. We'll start with VLOOKUP first and then we'll move to HLOOKUP. So let's take an example to start with. So let's say you have table A, which has several values. And one of the values is called as ID. And let's say this is your customer ID. Then you have a table, let's call it table B, which has details about this ID which was there in table 1. For each ID, let's say there is a variable VAR which has values X, Y, and Z for corresponding values of 1, 2, and 3. Now what you need to do is essentially combine these two tables using the ID as ID and create a new table which would have the same set of values which were there in table A, then ID, let's say 1, 2, and 1 again, and then the remaining values from table A. Finally, variable VAR from table B. So VAR corresponding to 1 was X, corresponding to 2 was Y. So this is essentially the outcome which you want. In this particular example, we would refer to table B as reference table or table array, right? So let's look at various parameters which are mentioned in this syntax. So lookup value is essentially the value of ID which you want to look at. So in this case, it is the value 1, 2, 1, which is there in this column. Table array, as I mentioned, refers to this table. Column index number essentially refers to the column number in the reference table. So in this particular case, your index number is 2. And range lookup for the purpose of this course should be set to 0, which means the exact match. So now let's go and do this on an Excel sheet.
So now let's look at a live demo of VLOOKUP and HLOOKUP. So this is the same data set which was shown to you in the presentation. So to start with, let's join policy details and customer details through customer ID. So the values which I need in these columns is name, gender, age, and then city. Apart from this, I'll need the product type, which will come from the third table, right? So to join the first two table, let's start with VLOOKUP. So what is the lookup value? The lookup value is A3. The table array or the reference table in this case is the entire customer details table. I'll change this to absolute referencing so that I can drag and drop the same formula to other places. Since I need name, this would be column number 2 and 0 for absolute match. So as you can see, customer ID 1 refers to Joe. That name comes over here. I'll just copy the same formula in all the remaining sheets and all the names get populated. For gender, I'll just need to make a few changes in this formula and then I can use it for gender. So I'll need to change this to A3 and this to 3 and you get gender. Similarly, you can get age, city. So now the only value which is remaining is product type. In order to get product type, we'll need to use HLOOKUP. The reason for that is because your product ID and product type table is laid out horizontally. So HLOOKUP stands for horizontal lookup. So again, lookup value would be product ID in this case. Table array would be this table. Again, I'll just convert it into absolute referencing. Row index number would be 2 because I want to pick up product type. And again 0 for absolute match. So I'll just drag and drop this for the entire table. So this is the final joint table. Hopefully you enjoyed this video. As I mentioned at the start of this video, VLOOKUP and HLOOKUP are one of my favorites and something which you will use a lot in day-to-day activities.
Now let's look at some advanced lookup and reference functions in this and the next video. So we'll explore concepts like how do you return the relative position of a value in a given range? How do you reference a cell based on row and column numbers? How do you access a cell based on cell reference input as a string? How do you expand the cell or range, move it by a given row or column? And finally, how to look up values from left of a search column, something that VLOOKUP cannot do. First, let's look at the match function. This helps us find the position of a search value in a table or a range. It's quite similar to VLOOKUP. The difference is that VLOOKUP returns the corresponding value against the search value, whereas match returns the position of the search value. Look at the syntax of match here. We have arguments lookup value, lookup array, and match type. And match type can be of three types. It can either be -1, which means return a match with exact or higher value, 0, a match with exact value only, and 1, which means return a match with exact or lower value. Match becomes truly powerful when we combine it with the index function, as we'll see in the next video. Just one thing, keep in mind that match is not case sensitive. Right, let's head over to Excel and understand the match function with example. Alright, so we have the employee data set here. And first of all, I want to know the date of joining for a couple of employees, A004 and A006. So we'll use the VLOOKUP function. You will be familiar with it at this point, so you can go ahead and do it as I do it. So what is a lookup value? That's our employee code. Table array is of course both these columns, employee code and date of joining. I'm going to freeze them because we'll be using this formula for the next employee as well. What's our column index number? That's 2 since we want the date of joining. And I want an exact match, so I'll say 0 and press enter, and there we are. So the date of joining is 21st October for A004, and we can verify it here, it's correct. Just drag this downwards, and for A006 we have the date of joining is 2nd August. So our VLOOKUP formula worked to perfection. Next, we need to find the position of these employees in the table range. That is where we use the match function. So it goes match. Our lookup value is the employee code. Our lookup array is this range. I am going to go ahead and freeze this because we'll be using it for employee A006 as well. And our match type is I want an exact match, so I'll say 0 and I'll press enter, and there we are. So match has returned position 4 for this employee in this particular table, and that's correct. And let's drag this down, copy the cell down, and there we are. So match has returned the position of A004 and A006 in the given range, which was this. This is not the row number in Excel, keep that in mind. Now I'll go ahead and unhide these columns that I wasn't showing till now. So what I want to do here is I want to find the position of these lookup values in this range. I want the position, right? This is where we'll use the match function again. And if an exact match is not found in this range, then I wanted to return the higher number, the next higher number. Right, so let's go ahead and use the match function. Match, our lookup value is of course M6. Our lookup array will be the range 1 range. And match type. Now I want to return the position of the next higher number if the exact match is not found. Remember the match type will be -1. Yes. Press enter and there you are. So 5, as you can see, is not available in this range. So what our match function did is it looked for the next higher value, which was 15. And if you count it manually, this is indeed in the 8th position in this particular range. Just drag this down and you have the position for the remaining lookup values. So what do you think went wrong here? Right, I did not freeze the cells in place, and that's why we're getting an error here. So let's go ahead and freeze this in place. And this is just to show you how important this is when we are performing any cell referencing. If you don't freeze it in place when you need to, you're going to get all sorts of errors and wrong formulas. So freeze it in place. Let's go ahead, copy it again. And now we have the correct positions. So let me take 35 example. Again, it's not present in this range, but if you see the next higher number after 35 is 38 and it is in the 3rd position. That's why we have 3 here. Keep in mind that when you use -1 as the match type argument, the data set of the range must be sorted in descending order as it is here. The next question now I want to answer is, what if I want to know the position of the lower number and not the higher number if an exact match is not found? Here we'll use 1 as a match type value. And this time your data set or your range must be sorted in ascending order. So let me go ahead and delete this column. We don't need it here, right? All right. So let me just delete this. Right. So let's go ahead and try it out again. So use match. Our lookup value will be R6, of course. Lookup array is this range. And a match type will be 1 this time. Press enter and there you are. And just Again, we have to freeze this in place. Very important to keep this in mind every time. And just drag it down, and there you are. So what the match function did here is it looked for 5 in the range, didn't find it, then it looked for the previous lower number, which was 4, and that's in the first position. That's why we got 1 here. And that's basically how match type works under the match function. As I mentioned earlier, and I want to reiterate here, the match function individually might not be very helpful, but when we combine it with the index function, it solves a great many problems. One of the examples, as I mentioned at the start of the video, is when you have to look up a value from the left of a search column, which you can't do with VLOOKUP. Now, I want to look at one of the most powerful functions in Excel called the index function. The index function basically returns a value or a reference of a cell which is at the intersection of a given row and column number of a given table. Right? The index is a much more useful function when we combine it with other functions, such as, you guessed it, the match function. I personally believe that it helps in solving a lot of complicated problems very easily. And once you practice it, once you have a good command over it, you'll definitely find yourself using it more often. So let's look at the syntax of the index function. Very straightforward. Three main arguments that you'll have to put in. One is the table range, the other is the row number, and the third is the column number. That's it. Let me head over to Excel and show you how the index function works in a practical scenario. Right, so here we have a certain range and we have a lot of numbers there. Our ask is to access the value of the fourth row and the second column in range. Right, so we want the fourth row in range and the second column, this one. So we want 22 and we'll use the index function to extract it. So index, our array of reference is the entire table range. Let's freeze that in place. Very important to do that every time. Right, what's our row number? It's 4. What's our column number? That'll be 2. Press enter and there you are. You've used the index function successfully and extracted the required value. That's basically how you use the index function. Now I want to show you another example of an index function, a slightly more nuanced and advanced example. Here we'll be looking up values from the left of a field with the index and the match function. Here we want to return the name of the employee based on the employee code. But as you'll see here, the name field is to the left of the employee code, so we can't use VLOOKUP here. So what we'll do is we'll use the match function first to find the position of the employee code in this range, and then we'll use the index function to extract the name based on the employee code. Right, so let's use the match function to do this. So match, our lookup value is this employee code. Our lookup array will of course be the employee code range here. I'm going to go ahead and freeze this in place because we'll be using this formula downwards as well. And match type, I want an exact match, so put 0 and press enter, and there you are. So employee A005 in the 5th position in this range. So just copy paste it downwards or drag it, and you have the position for the remaining 3 employees. Right. Let's head over to our match function and extract the name from these employee codes. So index, what's the array? It's this range, right? You want the name. So go ahead and freeze this in place. Row number now, that will be our position, employee position that we extracted using match. And a column number is just only one column, so just put 1 there and press enter. And as you can see, we have extracted the name successfully. Just let's just verify it. 1 2 3 4 5 Kunal A005. Perfect. Let me drag it down and you can just verify it in this range. We have successfully managed to extract the name using the index and match functions. One key point I want you to remember while using index with match is that both functions must have a similar height if you're finding the row number and a similar width if you're finding the column number. If you provide a different height or width, then you're going to get a different result, the wrong result. You won't get an error, but the output will be wrong, and that can really mess with your data set. Let me show you an example. What if I entered, instead of C3, by mistake I entered C4. I forgot to select the first instance in this range. So you'll see that the name our index function returned is Jennifer. And that's wrong because Jennifer's employee code 8004 and we wanted the name for 8005. So that's how the combination of the index and match function can go wrong. So just undo it. Just keep this in mind that both functions must have a similar height or width depending on if you're finding the row or column numbers. Alright, so all the lookup and reference features you looked at in this module will stand you in good stead when you use Excel in the industry. And these are often asked in interview questions as well, so start mastering them now. In this module, we will discuss various logical and error handling functions. So we learn about various functions like if, and, or, if error, is number, and so on. We learn how to combine two or more logical functions. And we'll also learn how to handle errors and also how do you check the type of cell contents, like is it a number, is it text, is it a blank cell, and so on. These functions are very useful in the data cleaning aspect of your project. In this video, first we look at these three functions: and, or, and not. The and function, very simple to understand, and it does exactly what it says. It returns true if all the conditions we supply are true, otherwise it returns false. The or function returns true if even one of the conditions is true, and not basically changes false to true and vice versa. And we'll see all of these three in action in Excel, and this is the syntax for all three of them. So let me head over to Excel and show you how these work. Right, so here we have the employee data set with these variables: e code, gender, department, actual hours, target hours, paper hour, and percentage. This is column basically tells me how close the employee is to achieving the target number of hours. As you can see, D3 divided by E3, actual hours divided by target hours. So that's all this column is telling me. Right, so let's take these functions one by one. First is the AND function. Right, so here I want to identify females who belong to the admin department. So we have two conditions here. We have one for gender and the other for department. So let's validate these two conditions. The formula to do this is and first condition is of course the gender, which should be female, and the second is that department should be admin. Right? Just press enter and you'll get false. This is because even if one of the two conditions does not meet the criteria and returns false, both of the conditions should meet it. And as I drag this down or copy the content, you'll see except one, all of the others are false. So here you can see both the conditions are being met, female and admin, and that's how and works. Next, let's look at or. Right here, if either of the conditions is true, either it's a female or the person is working in admin, it will return true. Let's see it in action. Or, that's the name of the function. Again, we'll follow the same logic. B3 is equal to female, and the second is of course C3 should be admin. This is or, press enter, and true. Why is it true? Because one criteria did meet what we are looking for, which is the department is indeed admin. That's why we get true. Just copy paste this to the other cells or drag it down. You'll see a bunch of true returns here. That's because at least one of those conditions, if not both, are being met. And that's basically how OR works. And if you are looking to get numerical values here instead of true and false, very simple, just multiply this by 1 and you'll get what you're looking for. Right? Just all I did was using the AND formula, I just multiplied that by 1 and I get 0 if it's false and 1 if it's true. And as you can see here, we get 1 for the true and everything else is false. I'll just undo that, but that is just to give an example of how it works. And finally, we have the not function. So just follow after me. Not basically returns true if a particular expression was false. It goes the other way. So let me just take this as the argument, press enter, and you'll get true because it was false here. And when you drag it down, and just one false here because this was true. That's how the not function works. Now, where do you think these functions are useful? Well, when you have hundreds and thousands of rows and columns that you're working with in the industry, you quickly want to understand how many conditions are satisfying what you're looking for, right? You might be looking for certain numbers in the data set that meet your threshold and so on. And these and or not functions quickly tell you how many observations or rows or columns you have that satisfy these criteria. Very helpful for doing quick data analysis. Now let's head over to our presentation and look at the error handling functions. We can perform all sorts of error handling operations in Excel to check whether an expression or a cell has an error or not. We can also use it to check whether a cell is number, is it text format, or is it just blank. Right, so we have these four functions to do it. And this syntax is very straightforward. Just enter the value after the function name and you'll get the answer or the output. So is error test if an initial value that you supplied, does it return an error or not? If it does, then we get true, otherwise we get false. Is number and is text and is blank, very straightforward to understand. If you want to understand if an expression or a cell gives us a number, you can use is number. Similarly, you can do it for text. And if you want to understand if a cell or a row or column has blank, then you can use the is blank function. Let me show you how these work in Excel. Right, so is error first. Just type after me is error, and let's take this particular cell, the percentage change, for example, and press enter, and you get false here. Because as you can see, there's no error here. We have an output, and that's what the is error function tells you. There's no error in that cell. Just drag it down or copy it, whatever you prefer. And we have two true conditions here. That's because, as you can see, we have an error here. That's why is error is telling me that yes, there is indeed an error in this observation and you should check it out. Why is there an error? I can quickly see that we have a couple of zeros, and the formula to calculate this percentage, as I mentioned, is actual number of hours divided by target number of hours. So with zero in the denominator, the answer will be infinity, and that is why you're getting an error here. So are you seeing why the is error function is so helpful? When we're doing any data cleaning in any project, whether that's an analytics project, a business intelligence BI project, even data science, the is error function quickly passes through the observations and tell me where the error is, and I can quickly understand where it is and how I can quickly correct it and move on. Very, very helpful for data cleaning. Now to check whether a cell or an observation has numeric or text value, you can use is number or is text. Let me show you how those work. So just type is number. Let's say, let's take the paper R column for example. Just press enter and true and drag it down. And of course you'll get true everywhere because this is indeed actually a numerical output. Similarly, you can use is text. Let me go with the department column, press enter, and it is true because admin is indeed a text column. And just drag this down, and there you have true for everything. So let me show you what happens if it is not a text column. Let's take this as D4, which is the actual number of hours, and you'll see that it returns false because this is a numerical column. This is not a text column. That's why we get false here. Let me just undo that. Finally, is blank tells me if a cell is blank or not. So just take anything. Let's take actual number of hours, press enter, and you get false because there is a value in this cell. And when you copy this down or drag it down, you'll get false everywhere because you don't have any missing values in our data set. So what happens if I remove a value? As you can see, this has now returned true. Again, I'm sure you already got this. This is very helpful when you're quickly looking to understand during the data cleaning stage whether you have any blanks in the data set, and if yes, how do you deal with them? And that's where, as the first step, the is blank function will help you out. Similarly, we have a few other logical functions in Excel like is even, is odd, is ref, is any, among others. The ones I've showed you are easily the most common ones that we use in the industry, but you can always go ahead and try out the other logical functions and just play around with them to understand how they work. In this particular video, we're going to talk about two more useful functions to generate conditional outputs, if and if error. The if function will sound very familiar to you if you've worked on any database or any programming languages. So let's say when I flip a coin, if head occurs, I select batting, and otherwise I go to bowl. Similarly, in the if function, we have one conditional statement, one success statement, and one failure statement. And the function if error basically returns a value that we specify if a formula evaluates to an error. Otherwise, it returns the result of the formula. And this is the syntax. Just have to pass two arguments there. What is the value? And if there is an error, what is the value you want to pass instead? I'm going to show you both of these in Excel, and I'll also add another thing at the end. How do you deal with multiple conditions and how do you use if statements there? We'll do that at the end of the video. Let's look at these two functions first. So I'll switch over to Excel. Right, so we have the same data set that we have been working with so far. So let's say that we want to give a bonus of 100 for those employees who've completed more than 15 hours of work. We'll use the if statement here. So we'll say if the actual number of hours, the hours they've worked, is greater than 15, then what's the value we want? If true, we want 100, right? That's the bonus we're giving. Otherwise, nothing, 0. Press enter and just copy this down or drag it down, and there we are. We get 100 if the condition number of hours greater than 15 is being satisfied. Otherwise, we get 0, and that's what we are seeing here. Now, let's say we want to give a bonus of 200 based on 100% achievement on working hours. So, percent achievement is basically column G here. So, basically, those who've completed their target, I want to give additional 200 to them. So, let's change this formula itself. Let's say if I'm going to say G3 is greater than equal to 100%, then give me 200 bonus, otherwise 0. Press enter. There you are. Just drag this downwards or copy it. And only two folks in our data set have achieved what we are looking for, which was 100% achievement. That's quite an eye-opening observation when you think about it. Out of the entire data set of employees in the organization, only two of them were able to achieve their target. Useful insight when you're in a managerial, executive, or leadership, or even in an HR position. But you'll notice that we have a couple of errors here. And we saw this earlier, right? The denominator or the target for them is 0. That's why we have two errors. How do we handle this? Well, we'll have to do something about the person achievement column. So let's take a business decision that if someone does not have any target, which is 0 in our case, then we'll consider that person achievement as 100%. It's just a business decision for the scope of this particular video. So we'll use the if error function for this. So let's say if error, what is the value? Value is actual number of hours divided by the target number of hours. That's basically what our person achievement is. And what do we want if it gives an error? We want it to give 100%, right? Press enter and just copy this down or drag it down. And as you'll see, both those errors are now reflecting as 100%. So clearly our if error function has worked. So that is essentially where you can use if and if error functions. Go ahead and practice it out. Finally, I want to talk about what if you have multiple conditions that you want to work on. This is where we use nested if statement. These really help us when we have two or more statements that we want to check. And I'm absolutely sure a lot of you will love working with this and will really appreciate it in your roles. So here's what I want to do. If the percent achievement, and we'll use the P column here since that's where we've rectified the error. If the percent achievement is greater than 100, then if that person is in sales, give him or her a bonus of 225, otherwise give the bonus of 215. And if the person achievement is not greater than 100, then just straight away return 0. So what you can do is you can just pause the video here, think about it, use a pen and paper, just use the Excel sheet that you're working on and try to work on this before you look at how I give you the solution. Right. So if percent achievement is greater than 100%, that's our first test. What if this is achieved, then we'll use the other if, right? If the department is equal to sales, then give him or her a bonus of 225, otherwise just give a bonus of 215. And if percent achievement rate is not greater than 100%, then just return 0. And there you are. Just press drag this down or copy it downwards, and there you are. So only two folks in the entire data set, in the entire organization, have worked more than 100%, repeat, have more than 100% achievement, and they were not in sales. So that's why they get 215 as their bonus. Nobody in sales achieved greater than 100% achievement. That's why they get absolutely nothing here. And that is essentially how you can work with multiple conditions and use nested if in Excel. Go ahead, try it out. And if you have any questions or insights to share, use the discussion forum of the course. I'll be very happy to connect with you. This module is all about the various statistical functions in Excel. This, I'm sure, will appeal to the inner data analyst within you. These statistical functions are useful for generating inferences about the data set, like what's the average, what's the largest value, what's the third largest value, how many people are below the sixth largest or smallest value. These are very important in terms of a data analytics profile. So here in this module, we'll discuss a ton of things. We'll talk about various statistical functions like average, minimum, maximum, standard deviation, count, count ifs, and so on. We'll also talk about things like how do you count values in a table based on one or multiple criteria, or how do we calculate average or numerical values based on single or multiple criteria, among other things. There's a lot to unpack here. So let's dive right into it. First, we'll look at how do we basically find out the minimum or maximum value, or how do we find out the largest or the smallest value in a given data set. Let me head over to Excel and show you how to do that. Right. So here again we have the data set about employees and their various features. So now we'll be looking to answer these questions. What are the minimum number of hours? What are the maximum number of hours? What's the third smallest value for number of hours and the second largest value for the same column? So as you can see, we'll be dealing with column F here, number of hours. So let's dive right into it. So to calculate the minimum number of hours, very simple. MIN is the function. Select your range, which is our number of hours column, and press enter. And there we are. The minimum number of hours is 12.33 in our data set. And to calculate the maximum, again, just max, that's the name of the function. Select the range and press enter, and there we are. So in just two functions, in just a matter of seconds, we now know the range of our number of hours column. So it's between 12.33 hours and 17.43 hours. Pretty cool. Next, we want to find out the third smallest value for number of hours. Here we'll be using the function small, and as you can see, we have two arguments here, array and k. Array is basically the range. Select that. K is essentially what are you looking for? How many? That's what we need to answer here. As you can see, we need the third smallest value. So our argument here will be 3. Press enter. And we're looking for the second largest value for number of hours. Here, your function is large and very similar argument, same range first. We need 2 here, right? Second largest value. Press 2, press enter, and there we are. We've quickly figured out what's the third smallest value and the second largest value. Again, the function does everything for us. Next question is, what if we wanted to find out how many employees are below this number? Let's say I want to find out how many employees are below the second largest value. These are questions organizations often need to answer. And this is where the different count functions come in handy. So let me head back to the slide and talk about a few count functions. Here we are. There are broadly speaking 4 count functions that you need to lean on when you're working on a data analytics project. We have count, count A, count blank, and count ifs. Count, as you can see the definition, returns the number of numerical values in a given range or a given data set. And you can see the syntax for each function here. Count A, on the other hand, counts all the values that aren't empty. Think of count A as count anything. The function count blank returns a number of blank cells in a supplied range, and count ifs is used to count cells based on given conditions. It could either be a single condition or a multiple set of conditions. You might be thinking of SUMIFs here, and that's a good comparison because essentially that is intuitively how the function works. Instead of doing the sum, it gives us a count. And let's see these in action in Excel. Let me head over there. So first what I'll do is I'll hide these columns because you need to bring up a new set of questions. Hide. Here we are. Alright, so essentially we'll be answering 5 questions here. Counting the number of employees, the number of male employees belonging to admin. Then we had another condition which is more than 15 hours. And finally, we'll be heading back to the question I asked just a few seconds ago about finding the employees who are less than the 6th largest value. How many employees are there? We'll get to it. First, let's see the count function. Alright, so count the number of employees. So is equal to count. What is the range? Which column do you think I should choose? Let me go with column A and press enter. Interestingly, I got 0 here. Why do you think that is? Because remember, count returns the number of numerical values. Right now, E is not numerical. This is a unique code, right? This is a string. This is not a numerical value. That's why we're getting 0. So instead of count, all you have to do is press count A And there you are, you have 15 employees in your data set. Perfect. You can of course use count if you're doing a numerical column. Let me show you an example. Count, let's take any numerical column. Let me take pay per hours, press enter, and there you are. You have 15 because it's a numerical column. Right. So let's count the number of male employees now. Which function do you think we should lean on out of these four? That's right. We should lean on count ifs. So let's go with that. Criteria range 1. Since we're looking at the gender, select that range is equal to male, press enter, and there you are. So we have 9 male employees in our database. Next, we have multiple criteria. So we have number of male employees belonging to the admin department. Again, very straightforward. Count ifs. The first criteria is gender. Select that. We want all the males there. Next, we want to find out admin. That's our department column. Select that entire range. Select admin, press enter, and there we are. So we have 3 male employees who work in the admin department. Next, we add another criteria, which is all of these people, number of male employees who have worked for more than 15 hours. You know what to do, right? Follow along with me on your machine as I do this. So our range first will be this, male. Second is our department, which is admin. And third is number of male employees to admin who have worked for more than 15 hours, right? So this is our third range, greater than 15, close it out, enter, and there we are. So there's just one male employee who belongs to admin and who's worked more than 15 hours. And finally, back to a question we had earlier. What if we wanted to understand how many employees are less than the sixth largest value in terms of number of hours? Very helpful in an organization to answer these kind of questions. So let's find out. We rely on the COUNTIF function again. We're only working with number of hours here, so select that. Right, our criteria is less than, right? So do less than, use the ampersand because we need to add a function here, and we use the large function. Why? Because we need to find employees less than the sixth largest value. Select number of hours, the entire range. How many? We want 6, right? Close it out, double brackets, enter, and we have it. So there are 9 employees who are less than the sixth largest value in terms of number of hours. And just to answer the question, what is the largest value? Let me just show you, is equal to large number of hours, and we want sixth largest, enter, there we are. And that's it. You're getting the hang of statistical functions already. Now, we'll talk about a few more common statistical functions that you'll often use in your role. These functions help us find things like the average, median, mode, standard deviation, correlation, among other things. So in this video, this is what we'll first focus on. We'll focus on these 4 functions: average, average ifs, mode, and median. Right, these are fairly self-explanatory if you've studied about them in statistics before. If you haven't, don't worry, we'll execute all of them in Excel in just a bit. So average is, again, it just returns the average of a list of supplied numbers. Average ifs calculates the average of the cells in a supplied range that satisfy multiple criteria. So again, your intuition of count ifs and sum ifs that we have studied before, that will come in when we study average ifs. And this is the syntax for that. We need to input the average range first. What is the average you want for which column, and then the criteria come into play. Then we have the mode, basically the most frequently occurring value in a list of numbers that we supply. And median returns the median or the middle value of a list of supplied numbers. And their function is here, mode and median. Mode is actually of 2 types in Excel, mode.single and mode.multiple. We'll be focusing on mode.single for now. That's the most common mode function in Excel. All right, let's head over to Excel now and see all of these in action. All right, so we have this data set. You're very familiar with it at this point. So what we'll do is we'll answer these questions and use the functions that we just saw. So average number of hours, median number of hours, the mode, and then we'll look at average ifs by looking at multiple conditions. Okay, first average. What is the average number of hours, right? So we'll be focusing on column F here. Very straightforward formula, average. Just select the range that we want, which is the number of hours. Select it, press enter, and there you go. So you have average number of hours is 14.694. The issue with average is that just one value, if it has a massive number or it has too little value, it can impact the output. Let me show you an example. Let's take F10 for example. It's 14.6 right now. What if while doing data entry we inputted it as 1200 by mistake? See how the average went up. It shot up from 14 point something to 93.7. It's a remarkable rise. Do you think this 93.7 is the correct representation of this column? It isn't, right? One value is driving up the entire range. That is where median comes into play. Let me calculate median and you'll quickly understand why median is helpful in these cases. So median range is of course the entire number of hours. Press enter and there you go. 14.35, which is basically the middle value in the number of hours column, is a far better representation of this than average, especially when we have this one outlier here. And let me just change this back to what it was. Let's say it was 14.7. And as you can see here, this average and median are now pretty much on the same scale. So this is where median can help you out. Next, let's find the mode for pay per hours, which is column G here. Mode, remember, is the most frequently occurring value. The formula is equal to mode. Select the range, press enter, and there you go. 41 is the most frequently occurring pay per hours value here. Perfect. Now we turn to conditions. How do we find the average when we have conditions applied to it? Right. So this will be average ifs, the average range. What do we want to find the average for? We want it for the number of hours, right? So pick that range. What is our criteria? Male employee, right? So that's our gender column. Male is our criteria. Close it out, press enter, and there you are. So 14.87 is the average number of hours for male employees. What is the average number of hours for male employees that belong to admin? Nothing too difficult here. We'll just use average ifs again. What is the average range? It's a number of hours. That's what we want the average for. We want this for males. So just type that out. Second is the male who belongs to admin. So that's a department column. Select that range, type in admin, close it out, press enter, and there you are. So the average number of hours for male employees that belong in admin is close to 13.6. And that's basically how these functions work. Let's now go deeper into statistical concepts, and I'll go back to the slide. Now, what I want to understand is the spread of the data. Why should I look at the spread? Well, looking at the spread lets us see how much our data varies in a given data set. One way to approach this, of course, is to calculate the range. You can just do the difference between the maximum and the minimum value, but that's a fairly crude way, and we do have some statistical functions to get the answer. One approach to answer this is the concept of quartiles. In the same way that median divides a dataset into two halves, we can further divide the dataset into quarters by identifying the upper and lower quartiles. The lower quartile is found 1/4 of the way along a dataset at 25% when the values have been arranged in an order of magnitude. The upper quartile is found 3/4 along the dataset at 75%, and the middle way 50% of the way through. That's basically a median. And that's how quartiles work. Another way to look at the spread of the dataset is STDV, or standard deviation. How far away is your observation from the mean? That's what standard deviation answers. Basically, standard deviation is a measure that summarizes the amount by which every value within a dataset varies from the mean. It effectively indicates how tightly the values in the dataset are bunched around the mean value. It's honestly the most robust and widely used measure of dispersion. So whatever concepts we've covered in this video, don't worry if you haven't heard about them or if you only have a vague idea. I've provided a link below this video to explain all these concepts in more detail. You can have a look at that. Right, so the other functions we look at are rank and correlation. Both them very intuitive explanation looking at the name. Rank returns the rank of a given value. Correlation basically tells us the correlation between two columns of features, or two or more actually, not just two. Let me head over to Excel and show all of these in action. So first of all, we're just going to hide this and bring up what we need to answer, which are these questions, and of course we'll calculate the rank as well. First, the most basic thing, let's calculate the range of number of hours. So it's a simple difference between the maximum value and the minimum value. So here we go, number of hours maximum minus the minimum of number of hours, the same column, press enter, there you go. So the difference between the maximum minimum values is 5.1. Now I want to look at the quartiles. So very simple formula, quartile, just select the range we want it for the number of hours, right? And we want the first quartile here, which is 25% of the way along the data set. And that's 13.645. Now let's find the second quartile, which is essentially the median. So again, quartile, select the number of hours, 2 since that's what we want, and there you are. So 14.35 basically is the median or the middle value in your number of hours column. And just let's verify that. Let's use the median function to understand this. Press enter and there you are. It's 14.35 as we saw. Perfect. Next, I want to find the standard deviation for number of hours. So we have two options to do this. We have stdv.p and stdv.s. P stands for population, S stands for sample. We will go with P since we have the entire population data set here. So just input the number you wanted for number of hours and that's it, press enter. So your data is basically 1.5 standard deviations away from the mean. That's all it tells us. To find the correlation, the formula is CORREL. We want to find the correlation between pay per hours and total payout. So select pay per hours first. Your second array is total payout. Close it out, press enter, and there you are. So there's a correlation of 86%, a very high correlation between pay per hours and total payout. This is because think about it intuitively. The total payout of an employee is very highly dependent on the pay per hours, right? That is why you see such a high correlation value there. Think of it from a business point of view. Whenever you are practicing these things in Excel, always put on your business hat and think about it. How would that affect a business? How does that make sense from a business point of view? Just keep thinking along those lines. Finally, we want to generate the rank for each employee based on the total payout. This could be for n number of reasons. For example, the organization wants to understand who's the most valuable employee. So you can use a rank to evaluate these kind of things. So let's see how to do that. So put the formula is equal to rank, that's the function. What's the number? That will be our H2. What's the reference? So use our total payout column, the entire range, press enter and there you are. So for employee A001, he or she is ranked 8th in the entire organization in terms of total payout. Just copy this or just drag this down and you have the ranks for everyone. Do you think this is correct? Well, what's happening right now is just notice what's happening. What's the formula bar here? As I scroll down, you'll see that the range is moving as I scroll down. So the total payout is moving downwards. There's nothing in cells H20, 21, 19, 18. So this is not the right formula. That's happening because we're using relative cell reference. Remember we studied that earlier. This is where it comes into play. We don't need relative cell reference here. The total payout will always remain the same. So let's freeze that using absolute cell reference. Just put a dollar sign before the rows and columns, press enter, and now drag it down. And there you are. Now you have a better representation of the rank. Just a point to remember, by default, Excel generates rank in descending order. If you want it in ascending order for some reason, all you have to do is just head over here and pass 1 as the third argument and press enter and you have the rank in ascending order. There you go. Basically, it's reversed itself. And that's it. That's how you can work with different statistical functions in Excel. Go ahead, again, practice, do the exercises, practice as much as you can. And if you have any questions, doubts, you want to share your thoughts, use the discussion forum of the course to post there. And I'll be happy to connect with you. Thank you.